Hello students, this is Gayatri Gupta from Jamshedpur Women's College. So today we will discuss the process of normalization that is very much required for the normalization of a relation, or we can say the normalization of database, so that we can avoid anomalies, means our database will not have any kind of anomalies like insert, update or delete anomalies. We will avoid such kind of we can say anomalies in our database, because we all know, so our database must be in a consistent state, and for making them consistent we should not have any kind of anomalies. Our integrity of the database must be maintained so that our database can be used worldwide, can be a reliable database to handle, to store huge amount of data in an efficient way. So database is actually a central place where you store your data, but those data must be managed efficiently so that you can easily access those data. So to store your data in an efficient way means efficiency in terms of its access, means you can easily access your data available in the database, you are securing those data, you are storing those data in an efficient way, you are utilizing the maximum space of the database in an efficient way. So normalization is a process which helps us to normalize our database so that we can avoid these three kind of anomalies, and our database will be in a category of a good database. So please have a look. Normalization. The process of decomposing unsatisfactory bad relations by breaking up their attribute into smaller relations is called normalization. Actually, it is a process of reducing anomalies available in database. The anomalies are insert, update and delete anomalies. We have already discussed about this. So normalization is a process of reducing those anomalies from the relations. So it is done by applying different normal forms. So normal form means it is a condition using keys and functional dependency of a relation to certify whether a relation schema is in a particular normal form. So by applying this normal form, we can normalize our relations, we can break our relations into different smaller relations, which will avoid insert, update and delete anomalies. Before discussing any normal form, we first want to focus on the role of keys. Before that, we should identify a type of keys so that we can understand the process of normalization. A super key, we all know super key is in a relation schema is a set of attributes which may be a subset of the relation with the property that no two tuples T1 and T2 in any legal relation state R of R will have or will be equal, will have the same value. So super key means it has a property that no two tuples will have the same values, means every tuple will have unique values. Now, what is a key? A key is also a super key with the additional property that removal of any attribute from the key will cause key not to be a super key anymore. Means if we avoid or if we remove any part of the key which will make that key not a super key. means a key can be a combination of values. So if we remove any one of the value, it will lose its super key property. Now, if a relation schema has more than one key, each is called a candidate key. More key means, suppose I am giving one example. In a student relationship, in a student relation, we may have different attributes which will hold some related values of a student. So there may be some attribute which can play a very important role to identify all the other attributes or the values of the relation. So like student ID can be taken as a super key or key. Enrollment number can be taken as a key. So except this super key, means student ID and enrollment number, there may be some other attributes which can also play very important role to identify the tuples in a relation, which may be a single value or which may be a combination of values. So those combination of values or value other than super key and primary key are known as candidate key. So one of the candidate keys is arbitrarily designated to be the primary key and the others are called the secondary key. So in a list of keys, or we can say a list of keys which is capable to identify every tuple of the relation can be treated as a key, and one of them can be a primary key and the others can be said as a candidate key, or we can say secondary key. Now, we always use the word prime attribute and non-prime attribute. So let's discuss prime attribute. So prime attribute means it is a member of some candidate key, means it must be a part of the candidate key. Means a key element or any attribute which is a part of the candidate key can be taken as a prime attribute. And a non-prime attribute is not a prime attribute, that is, it is not a member of any candidate key. So this is all about the keys, that's like super key, primary key, secondary key, candidate key, prime attribute and the non-prime attributes. So all these informations are very much essential to understand the process of normalization, because normalizations or the normal forms are based on the type of keys and the type of functional dependency. So I hope this video has benefited you. So this information will help you to understand the process of normalization. Thank you. In the next video, we'll understand and we'll see the process of normalization and different normal forms. Thank you. Till then, bye bye.